My name is Robin Murray, and I'm an engineer at the National Renewable Energy Lab working on wind and water energy systems. Over the last decade, NREL has been working closely with Verdant Power to help bring their tidal energy system from a working prototype to commercialization. In this research measurement campaign, NREL is using our expertise in blade design, manufacturing, and characterization to validate a novel thermoplastic composite system for water turbines and measure the loads on an operational tidal turbine.
We are standing in the NREL Flatirons campus building 251 High Bay. Traditionally, this high bay has been used for wind turbine blade structural validation. More recently, we are starting to do water power work in this facility. The primary objective of this research project is a comparison between thermoset resin systems and thermoplastic resin systems. Traditionally, composites have been made using thermoset resin systems like polyester resins or epoxy resins. These two-part chemical systems, when mixed together, form a resin that, once cured, is cured for life. A thermoplastic resin system has the potential to be recycled and reused at the end of its life.
Thermoplastic composites have been shown at a small scale to have improved seawater or saturated properties, but nobody's done this at a large scale yet. So we're really interested in looking at how these materials can potentially improve the structural properties of a blade at a full scale. Verdant's role in this project is to supply us with the blade tooling and the geometries so that we can produce identical thermoplastic blades to their epoxy blades that they've already manufactured, as well as to operate and deploy and retrieve this turbine in the East River for the 6-month deployment period. This work will demonstrate a potentially game-changing material for marine applications at a meaningful scale, as well as produce loads data for a full-scale turbine that we can use to validate design tools to de-risk future deployments by the industry as a whole.
We couldn't be doing this without the strength of our collaboration with our partners. Verdant Power in particular, they're allowing us to use their site and use their turbine to test new technologies such as the thermoplastic blades that Robin's working on. We're also working with other national labs, Sandia National Lab and Pacific Northwest National Lab, to answer a range of questions under this project that are really fundamental research questions that are facing the tidal power industry. And of course, we couldn't be doing this without DOE support. We're so grateful for their contribution and leadership in this industry.
Our systems are lowering the cost of energy due to their scalability, ease of deployment and retrieval, and they can be used by local marine engineering companies all over the world. We're excited to deploy the tri-frame and turbines and then convert this project to a fully functioning demonstration facility for turbine performance, distributed generation, energy storage, electric vehicle and vessel charging stations, and clean water and green hydrogen production. Together with the Department of Energy's Water Power Technologies Office and NYSERDA, Verdant Power will be helping build sustainable communities and solving some of marine energy's biggest challenges